How's it going, everybody? So today we're going to be talking about properties of logarithms. So the three big properties of logarithms that we need to know for this section is going to be the product property, the quotient property, and the power property. Now you'll notice I already have them written here, so that way you guys can start writing them down. And if you need to, go ahead and pause the video so you can start with me. But let's jump into the product property. So for this one right here, what it states for logarithms is that I can take the same logarithm, the same base, and I can break it apart and do log base b of m plus log base b of n. Okay, so I can break it apart like that. And a lot of people like to say to expand, okay? They expanded the logarithm. Now, for a quotient property, anytime we deal with division, it's going to be subtraction. So now I have the log base b of m minus the log base b of n. Okay, so very similar, but just instead of a plus, it's a minus. Now, the power property, okay, commonly forgotten, but very much important. What we're going to do is we're going to take this value of n and we're going to bring it, okay, to the front. Now, some of you may know that already, but this property can be forgotten sometimes. So log base b of m. So notice how the n is now in front of the log now, okay? So with those three properties, we're going to go ahead and start, I guess, applying them to some real examples. So let's go ahead and do a property for the product one, okay? So say I were to do, let's see, log base 2, and I have 21, okay? And to evaluate this log, okay, we're going to use, okay, so we're going to use log base 2 log base 2 of 3 and log base 2 of 7, okay? So if I wanted to expand log base 2 of 21 into more logs using the ones I've given you, you would have log base 2 of 3 times 7, right? Because we're using the 3 and the 7, okay, to expand 21, because 3 times 7 is 21. But then, okay, as we keep going, we can then break that apart and say log base 2 of 3 plus log base 2 of 7, okay? So right now what I'm trying to do is just get you acclimated to using these ideas and concepts. Eventually you'll get good at looking at numbers and being able to say, oh, in order to break up a 21, I could use a 3 and a 7, and things like that. Now let's try another one. All right, let's try this one. So say I gave you log base 4 and then 4x, okay? So what you would do is you would break it apart, right? Because it's the product property. You'd have log base 4 of 4 plus log base 4 of x. But I did this one because it's a continuation of last lesson, where what do we do when the base and the number is the same? Well, they simplify, right? And so this would actually be 1 plus the log base 4 of x. So things do have the ability to simplify, okay? We just got to remember our properties. Now, I'll do one more. Let me erase this. Alrighty, guys, so say I gave you a problem like this, and I said use log base 6 of 5 and log base 6 of 8 to evaluate in this current logarithm. Well, as we know that 40 is multiplied by 5 and 8 to get it, so we can go ahead and do log base 6 of 5 times 8, right? And then we can expand that multiplication by doing log base 6 of 5 plus log base 6 of 8. And so this right here would be fully simplified because nothing else can go ahead and simplify out, like for instance, the 6 and the 5 are not the same number, 6 and the 8 are not the same number. So we would just leave it as is, okay? So this is a very basic introduction. Of course, things will kind of ramp up a little bit, but let's talk about the quotient property now. So let me erase this. Alrighty, so say I gave you log base 2 of 3 divided by 7. Well, clearly that is division, right? Which leads us to do our quotient property. So what I'm going to do is it's the top minus the bottom. So it's going to be log base 2 of 3 minus log base 2 of 7. And there you go. You finish that one. Now I'll try this one. If you have log base 7 of 1/4, it's always top minus the bottom. So you'll have log base 7 of 1 minus log base 7 of 4. And then you're done. So a lot of these do not have heavy, intense math. It's just making sure that we're applying the property correctly when we have like these different scenarios. Now let me try implementing a scenario that has a mixed combination of both division and multiplication. Okay, so let's kind of see if we can expand upon this thinking using both properties at the same time. All right. So what we have here is we have the log, or let's do ln so you guys can see that. Ln and log mean the same thing, okay? They're both types of logarithms, okay? And what I mean by they mean the same thing, I mean we handle the properties the same. So if I give you the ln of x over 3y, we're still going to handle these properties the same, okay? Now, looking at this right here, we see that we have a division and there's a multiplication in the denominator, okay? There's a multiplication right here. Now, you might be wondering, which one do you apply first? Well, the truth is you can apply them actually in any order that you would like to, okay? But in my opinion, I think for this scenario right here, the easiest is always to do the division first and then to apply the multiplication one next, okay? So in my opinion, division first, multiplication second. So looking at this right here, oh, let me get my pencil back. We have the ln of x minus the ln of 3y, okay? And the reason I like that is because now we've gotten away from fractions and now we're officially dealing with just nice whole numbers. Now, the 3y, of course, we're going to break this apart with addition, right? So what we have here is we have the ln of 3 plus the ln of y. Okay, now you'll notice I put parentheses around this entire logarithm because, guys, if you remember, this negative is being applied to this ln, right? Well, this right here, this one right here, even though it's expanded, it's still this logarithm over here. Okay, so don't feel like because you expanded it, you changed the numerical value. That's not the case. So you still have to understand that that negative is applied to now two separate logarithms, okay? So just be aware that this is now being distributed to both, okay? A common misconception for a lot of people. Then bring your ln of x down, okay? So you have the ln of x now minus the ln of 3 minus the ln of y. Okay, so a lot of subtraction going on. But if you feel like you were pretty confident on that one, you are right where you need to be, okay? And we'll try to see if we can find another example about a mixed one later on, okay? But now I want to go ahead and talk about a power property, okay? And then I'll go ahead and try to incorporate some really good examples. So let me erase this. Alrighty, so here's an example. You've got log base 2 of 7 squared, okay? So looking at this right here, using the power property, what this means is we're going to take this value that's right here and we're going to put them right here. So let's go ahead and do so and see what it looks like now. It looks like 2 log base 2 of 7. Now please do not under any circumstance think or try To be like, oh, so these are gone? No, how dare you? Do not do that. That's bad. Okay? No bueno. So what you got to understand is that they are left alone, and it is still 2 log base 2 of 7. Do not try to simplify. What you're trying to do in your head is you're trying to somehow do this, and these simplify, but not when the 2's over here. Okay, so just be aware of that. Okay. Now, with that being said, since that is a fairly simple property, let's do one more and then move on. So I've got log base 2 of 5 to the 4th power. Well, that means the 4 is going to go right there. So we've got 4 log base 2 of 5. And then you're good. All right. So now let's jump back into where we have a mixed, mixed logarithm. And I'll also throw in some ideas and concepts that we've learned from radicals as well. So be ready for that, because you know how Mr. Farmer likes to make things a little difficult, to challenge your thinking. So let's try this one on for size. Say I gave you the log base 5 of the cube root of x squared times y. Now I know a lot of you do not like having the radical there, so let's change that radical into a rational exponent. We got to be comfortable doing that, okay? It'll definitely get you out a lot of mathematical binds if you know how to do it. So what we have here is the x squared times y. Now this whole quantity is raised to the 1/3, okay? Now remember, what can we do first? Well, we have to do the power property first, okay? So in terms of operations, the power property is always addressed first, and so we're going to bring that 1/3 to the very front. Okay? Now, looking at this right here, we can now, since this is multiplication inside here, we can break apart this logarithm, okay, into our 1/3 log base 5, okay, of x squared, plus our 1/3 log base 5 of y. Now you might be going, whoa, Mr. Farmer, what's with the 1/3? Why did it travel? Well, remember, this 1/3 is multiplying this logarithm, this log base 5 of x squared times y. If I were to put some parentheses around it, imagine what's inside there expanding, and then you distribute the 1/3 to each individual term, okay? And now that's what went down right here on this step, okay? Now, looking at this part right here, we're almost done, but we still have a 2 next to that x squared. Well, let's address that 2 by bringing it to the front. No pun intended. Bringing the 2 to the front. And so we then have a 1/3 times 2, right? So that's going to be a 2/3 log base 5 of x plus a 1/3 log base 5 of y. And now, yes, we are officially done with this problem, okay? So now you can kind of see how all these properties kind of interact with each other to fully expand. So remember, we're kind of calling this process expansion, okay? So let's try another one. All right, let's try this one. Alrighty, so here once again we do have ourselves a division, okay? So remember, I like to handle division first. So you have the ln, okay, of 6x squared minus, because remember it's top minus bottom, the ln of y to the 4th. Now, looking at this scenario here, these logarithms will both have their own individual thing going on first. But let's handle the initial log, okay, first, and then we'll do the second one. We see that it has multiplication similar to the first problem, so we can break apart this ln into the ln of 6 plus the ln of x squared, and then of course you still have minus the ln of y to the 4th. Now we have some powers attached to some of these terms or these variables, and so we can bring those to the front. Ones that I'm looking at specifically now is this 2 and also this 4, okay? And so by bringing them to the front, I have the ln of 6 plus 2 ln of x minus 4 ln of y. And that right there is our answer. Okay? Fully expanded. Now let's do one last and final one, and then what I'm going to encourage you to do is we're going to flip this on its head, and now we're going to go from expansion to condensing, okay? But let's do one more example first. Let's try this one. We've got ourselves a log base 7 of 5 square root of x, okay? So when looking at this right here, the first initial thing that you can do is you could expand this using the product property, meaning log base 7 of 5 plus log base 7 of the square root of x, right? Now remember, you do have the ability to change a radical into a rational exponent by going ahead and saying log base 7 of 5 plus the log base 7 of x to the 1/2, okay? Now with the power property, we are now going to go ahead and move that 1/2 to the front, and we should have something like this. And then, believe it or not, we're actually done there, okay? That's it for that one, okay? So just apply those properties like I did in this video. You should be just fine, okay? If you do have any more questions, please reach out to me and let me know. But now let me do a couple of examples where we do some condensing, okay? Now, I won't, harp on it too much. I'll let you have some more practice, but I just want to make sure that you've at least seen it with me versus just by yourself first, okay? So let me pause this and erase. All right, so let's try this one on. So this one right here, you have 6 ln of x plus 4 ln of y. Well, looking at this right here, we have to think in terms of, going backwards. And we know that we can take these numbers on the outsides and convert them back into exponents, okay? So let's go ahead and do that. So I have my ln, ln of x to the 6th power plus ln of y to the 4th power. Now that we have that addressed, we can now address the product property by condensing it down into ln of x to the 6th times my y to the 4th power, okay? And believe it or not, since there's really nothing to multiply together, we would go ahead and stop there and everything's good to go. Nothing to it, right? Now, let's say that we have something like this, and let me erase. Because I know this could be on the minds of many. Okay, say I gave you something like, 2 log base 3 of 4, and then we had plus log base 3 of, let's say another 2, and then we do minus log base 3 of, and then we'll do of like 5. So the way we handle this is first go ahead and fix the number in the very front, okay? And so by bringing that to the 4, you now have log base 3 of 4 squared plus your log base 3 of 2 minus your log base 3 of 5. Now you do have to simplify 4 squared. 4 squared is 16, right? So with that being said, you could go ahead and do 16 right here. And now what you're going to do is start applying these other properties. Now, which one do you apply first, though? Do you apply the addition one first or the subtraction one first? And it's going to be the addition first, okay? So by doing so, I'm going to have log base 3 of 16 times 2. and then minus log base 3 of 5. Well, 16 times 2, that's going to be 32, right? And so with that being said, all we have left is the subtraction. Now it's always, when you do the expansion for that quotient, it's top minus bottom. So that means the 32 is going to be on top, right? So you have log base 3 of 32 over 5. Alrighty? And there you go. That is going to be the condensed version, okay, that you're looking for. The condensed version. Now let me see here. What is a possible another one? Oh, let me erase this and let's do another one. Alrighty guys, let's try this last one. So this one right here, you're going to notice, and hopefully you are very careful, there are two different bases here. There's one those are 5s, and then there's a base that has one that is a 2. So I'm going to show you how we interact with this type of problem. So with this being said, okay, let's address the things that we see initially, like the 4 in front of the log base 2. We can bring that to the front, and so I have log base 5 of x plus log base 2 of 3 to the 4th power minus log base 5 of 8. Now, looking at the bases, we see that the two log base 5s, those can actually interact with each other. But the two log base 5s cannot interact with the log base 2. They're not the same log. So, with that being said, we can actually rearrange this problem to be log base 5 of x minus log base 5 of 8 plus log base 2 of, and then we can simplify 3 to the 4th power, that is 81. Now, we know with subtraction, when we go to condense that down, that's going to be top minus bottom, so it's x on top of the 8, so we have log base 5 of x over 8, and then we have plus log base 2 of 81. And so because there's nothing else that we can do to simplify this problem, we would actually leave it here with these two separate logs. I just wanted you to go ahead and see this so that way you wouldn't want to go, oh, so you mean now I got to go ahead and do somehow 5 times 2, and you'd have log base 10, and then you'd have x over 8 times 81. I've seen some weird stuff in my day. Do not do any of that. That is totes no wins, okay? So hopefully you found this video informational. Let me know if you need any help, guys. I'll be posting the homework soon, okay? Definitely let me know if you need anything. Bye, guys.